Hello everyone, good evening to all. Welcome to Metallurgy by C. Patel. Today we will discuss a problem which is asked in GATE 2017, and this problem is related with neck size calculation in powder metallurgy during sintering. So the question is, tungsten nickel compact is prepared by liquid phase sintering at 1500 degrees centigrade. If the size of tungsten grains is 40 micrometer and the interfacial tungsten and tungsten nickel energies are 0.52 and 0.32 joule per meter square respectively, the predicted neck size in micrometer of sintered tungsten grain size is, we have been given MP of tungsten and nickel are 3410 degrees C and 1453 degrees C respectively. So we need to calculate the neck size. So first we will write what are the given. MP of tungsten is 3410 MP, sintering temperature is 1500 degrees C, and interfacial energy of tungsten nickel 0.32 and tungsten is 0.52. Okay, so now when sintering will be done at 1500 degrees C, then you can see here the melting point of nickel is low as compared to 1500 degrees C. So nickel will melt and it will go around the neck formation, and tungsten, since has higher melting point, so this will be in solid condition only. So I will try to draw the diagram. So just before the sintering, this is tungsten, and somewhere in the middle nickel will be also there, nickel particles will be there, and nickel will be there. Okay, and when sintering will take place, then this nickel will melt and this tungsten will fuse together. This tungsten and tungsten particle will fuse together. So after this, the structure will look like this. Okay, so this is tungsten particle, this is tungsten, and here molten nickel. Okay, so nickel will be in molten stage. Now to solve this problem, we need to first assume this contact length. This contact length, if we see in two dimension, you consider this sphere and sphere, this contact length is x, and this is the neck size. Neck size, why this is the neck size? Neck size basically neck is basically term the contact between the particle. This contact will take place, if you see in three dimension, then this will be a circular contact. You can imagine a sphere and another sphere, when they are in contact, then they will contact in a area which will be in the form of circle. So to give you the feel, I have taken to a sphere sphere like thing. So I have taken egg. So I'm sorry about this. Some vegetarian guys may be offended, but I'm not here to offend this. You can see here, imagine these two are tungsten particle. So when they are in contact, you can hear the contact, and when they are compressed, because in this zone the mass has been compressed. So if you compress like this, okay, compress like this, then what will form? This will form a circle. Okay, so this will form like a circle. They will contact here like a circle. So basically this x which I have represented here, so x is the diameter of the circular contact. and that is called as the neck. Okay, so I will draw this diagram again and I will try to solve. So okay, tungsten, tungsten. Okay, now we know the interfacial energy, since now nickel will be present in molten state and this is in solid state, so there will be a surface energy or interfacial energy, that is gamma, tungsten and nickel. Here also gamma, tungsten and nickel, this contact surface is tungsten and tungsten. Okay, so this will make an angle that is known as theta, and this is known as dihedral angle. Okay, this is known as dihedral angle. So if you draw a line, straight line, then this angle will be theta by 2, this will be theta by 2. Okay, now and this is the center of the two particles. Now if you draw a line between these two, the junction, just at this junction, if you draw a straight line over here, then this angle, if you measure, that will be again theta by 2. So we know this is the radius, this is the radius of the particle, which will be equal to d by 2. D is the grain size, so we will write here d is equal to grain size. Okay, now equating the energy, so we will equate the energy in y direction, so in y direction this will be the formula gamma tungsten nickel cos theta by 2 plus gamma tungsten nickel cos theta by 2 is equal to gamma tungsten tungsten. So 2 gamma tungsten nickel cos theta by 2 is equal to gamma tungsten tungsten. So this implies cos theta by 2 is equal to gamma tungsten tungsten divided by 2 gamma tungsten nickel. So the value of this will be, we have tungsten 0.52 divided by 2 into 0.32. So if you calculate, then we will calculate theta by 2 is equal to cos inverse 0.52 2 into 0.32. This will be equal to, here I am using calculator. In the examination you will be given scientific calculator, so I am calculating it 0.52 2 into 0.32. So theta by 2 will be around 35.65. Let me check. I've used the same value. Okay, actually the value of gamma tungsten nickel is 0.30, so we need to use here 30. So after taking 0.30, this will come around 29.92. Okay, now yeah, now coming to the next size calculation. So we have got here a right angle triangle with angle theta by 2, so we need x by 2, since the complete line is x, so this will be x by 2. So here we'll use this formula, sine theta by 2 is equal to p by h, so x by 2 divided by d by 2. This implies x by 2 is equal to d by 2 into sine theta by 2. This implies x equal to d into sine theta by 2 is equal to d. So d is how much? 40 micrometer, and sine theta by 2 is equal to sine 29.92. So this will come around 40 into sine 29.92, come around 19.95 micrometer. So this will be around 20 micrometer. Okay, so this will be around 20 micrometer. So 20 micrometer will be the right answer. So this is the correct answer. So guys, hope you have understood this. The thing which need to remember this in this question is the formation of neck and the structure in which this neck is formed. So the neck is formed in this structure, and this length, basically this length or this dia, because it's a circular contact, so this dia is basically the neck size. Okay, so hope you will be clear now. So thank you.